Hi everybody, this is Dr. Dadu presenting first order designs in response services and now happy listening. Introduction. Well, here I've avoided as much as possible the installation of additional R packages. The first order designs in response service and R is the topic of this presentation. I assume that my audience are aware of response servicing and that the task just boils down to presenting our reusable codes that will automate the statistical analysis. The reference material still remains Cochrane and Cox. First order designs in response surfaces are now. In some factorial experiments, all factors represent quantitative variables. Consequently, the yield or response, which here denoted by y sub j, is thought of as a function of the factors. That means you can write y as a function of the xi's. Well, the pertinent function is known as the response surface, even this, where the e sub j is the error. Now, the fitting of a polynomial can be treated as a particular case of a multiple linear regression because polynomial, the least in the number of polynomials is the linear, which is linear. Now, the second degree polynomial is the quadratic and is the product of two linear. The third is the cubic, which is the product of three linear equations, like that. Now, that means OLS is useful. OLS, and to use OLS, you just identify your matrices, your X matrix, your Y matrix, X prime X inverse, X prime Y matrix. These two are the ones which you are going to fit beta hat. The equation would be y equals x beta plus the error. And when it is fitted, it will be y equals x beta hat. Now, information on the data. What we have here is for the sake of illustration. So we're going to use an hypothetical data. We are going to assume that we have a 2 to power 3 factorial experiment where the data are just 3, one of which is the time of reaction, the second, temperature, the third, quantity of ingredient. The time of reaction is taken to be between 5.5 and 6.5 hours. The temperature is taken to be between 260 degrees Celsius and 340 degrees Celsius. Then the quantity of ingredient is between 1.4 and 1.8 grams. Since each X variable takes two different values, the calculation can be simplified by coding. You code in such a way that the upper level will bear +1, the lower level will bear -1. A relation that can help you to do so in this case is this. Now, x1, time, is talked about, so we see time, -6. Where is 6 coming from? 6 is midway, mid value between 5.5 and 6.5, then divided by half. Why? Because the interval between the two is just 1 hour. Half of that interval is what you divide with, and that will be 2 times this. Now, x2 is temp minus 300. Temperature, temp. 300 is midway between 260 and 340. And the difference between the duo is 80 degrees Celsius. Half of 80 is 40. S3, quantity minus 1.6. 1.6 is the midpoint between 1.4 and 1.8. And the difference between them is 0.4. Half of 0.4 is 0.2. The data and the manual computation. This is the data after coding, that is. And this is the yield, the y's. Now, the matrices x prime x, x prime y, inverse of x prime x, as easy as that. So the population of inverse of x prime x and x prime y will give you the coefficients. That's the intercept, the coefficient of x1, coefficient of x2, coefficient of x3. And this is the ANOVA, supposedly obtained by hand. Now, this is the response surface. Right. What about the provisions of R concerning the problem? Now, X naught, you know, X naught is came into being because of beta naught that we want to put in there so that this equation will be possible. Now, X naught is not actually a variable, it's a dummy variable. It's to make things work. So, but that is why it's bearing 1, 1, 1, 1 all through. Because the beta naught is 0. So x1, x2, just as containing data, then the y-axis. And this is the data.frame. This time around, we can see the data. And the model, linear model is y, model on x0, x1, x2, x3. Summary of G. By the time you invoke this linear model, it will have, R will have done the work, and you can ask for the summary, the coefficient, and ask it to produce the ANOVA. Everything is here. Now, this is the regression that is being fitted. If you look at 170.25, let's go back to the hand calculation. You see, the intercept is 170.2. Now, x1, 11.75, x2, minus 5.25, s3, 4.0. Now, these are the coefficients as requested. This is a summary of the fitted model. And this is the ANOVA, all as requested. And you can see, now, if you compare this ANOVA with the uncalculated ANOVA, you see that it says linear, all the variables are put together here. But that's robbing us of their contributions. If I had them up, I won't know the contributions of each. But X handles them separately so that we can know the contributions of each. This is the farthest I intend to go on first order response surface designs and even design of experiment as a whole. Next time, by God's grace, I intend to do videos in another area of statistics. Please like, share, and subscribe. Thanks for listening. Bye for now. See you next time by God's grace. Thank you. God bless.